Okay, so now we're going to look at our next transformation, which is reflections. Reflection is a transformation that flips the pre-image points over a line. The line is called the line of reflection, and that line is always the perpendicular bisector of the segment that would connect the pre-image point to the image point. And we'll look at that, this last part in a moment here. Now, with reflections, we also have mapping versus proper notation. And so with mapping notation, we are going to learn 3 different sets of rules for reflections. We're only going to learn 3, but I'm going to just give you a quick example right now. So remember, this capital letter just means that it's the name of the transformation. It doesn't mean much of anything. So that's transformation H. We're going to take all points x, y, and we're going to make the x values negative, and we're going to leave y alone. And we're going to learn actually what type of reflection this is in a little bit. But that would be an example of mapping notation for a reflection. Now, proper notation, you can use capital R, lowercase r, I don't care. I'm going to use capital R for reflection. And then in your subcategory area, we write down the line of reflection. So maybe you're reflecting over the y-axis, maybe you're reflecting over the x-axis, maybe you're reflecting over the line x equals 3. Whatever line you're reflecting over, that goes in your subcategory. And then you got to state what shape you are reflecting. I'm just going to stick with triangle ABC. And then what the image is of that pre-image. Triangle A prime, B prime, C. All right, so reflections are isometric transformations, so they do take on all the isometric properties, but they also have their own properties. So typically, the distances from the pre-image points to the image points are not the same. So for example, A to A prime is not the same distance as B to B prime. So we're going to write that down. A to A prime does not equal B to B prime. Unlike in translations, where A to A prime, B to B prime, and C to C prime are all equal, in reflections, the distances from the pre-image points to the image points are not equal. Now, since they're isometric, AB and A prime, B prime would be equal, but that's an isometric property. In reflections, orientation reverses. So what that means is that if I pick a starting point on my pre-image triangle, it does not matter which starting point you choose. Let's start with B this time. And if I move clockwise around this triangle, I go from B to C to A back to B. But if I start at B on my image and I go clockwise along this image, I go from B prime to A prime to C prime to B prime. So I don't go B, C, A on my image, it's backwards. So that's what I mean by orientation. The orientation reverses in reflections. And that is due to the fact that we took this triangle, ABC, and we flipped it. That's why the orientation reverses. Now, the line that we are flipping it across, this is called line M. This is called the line of reflection. And the line of reflection is always the perpendicular bisector between your pre-image point and your image point. So if I were to connect point A to A prime together, my line of reflection would be perpendicular to that line. And point A to my line of reflection would be congruent from, or to the distance from the image point A prime to my line of reflection. So that's what I mean about it being the perpendicular bisector between the pre-image and image points. And then reflections do have special points. If you have a point that is on the line of reflection, like point D here, then your point will not move, because if we're trying to reflect point D over line M and it's on line M, then there's no line for it to, or there's no way that it can move to a different point on the, to a different location on the graph. It's just going to stay on that line. All right, so let's get started. So in number 1, we are reflecting point A over line M. This is line M here. So what we want to do is we need to travel perpendicular to line M, and then we're going to travel the same distance perpendicular on the other side. So point A would wind up on point C. All right, next one. We have point C that we're reflecting over line H. So I'm going to travel perpendicular to line H, and then the same distance perpendicular on the other side to get that point C would map onto point B. Notice that I said the word map because it's still a transformation. We're mapping points on top of each other. So now I'm going to reflect point D over line H. So I'm traveling perpendicular to line H, and then perpendicular the same distance on the other side, I wind up on point A. Going backwards with reflections isn't too bad. This time I'm going backwards. I'm reflecting point B over line G. So I'm traveling perpendicular to line G, and perpendicular on the other side would put me at point A. And then I'm reflecting point D over line N. Be careful, I need to travel perpendicular to line N, and perpendicular on the other side, I wind up with point B. And then lastly, point D, I am reflecting over segment BD, which since D lies on top of segment BD, and what that would mean is that point D is going to stay on that line of reflection, so D would map to itself there. All right, so now moving on to these actual coordinate graph reflections here, we are going to reflect over the x-axis, the y-axis, and the line y is equal to x. And notice I used capital R's sometimes and lowercase r the other times. I'm not going to be picky about whether it's capital or lowercase. But number 7, we are going to reflect over the x-axis. So that's this line right here. And since point B and C are on the x-axis, and point B prime would stay on the x-axis, and C would also stay on the, C prime would stay on the x-axis because they are on the line of reflection. Now point A, if we count, it is 1, 2, 3 units away from the x-axis. So we are going to go 3 units away on the other side of the x-axis. So A prime would wind up right here. Now, it does say now to write our rule in mapping notation. And so we need to determine what happened between each of these 3 points to figure out our rule. Well, B and C stayed the same, so that's not going to be useful to us to use that. But let's look at point A. Point A was originally at the point -2, 3. Point A prime is at -2, -3. So actually what happened between these 2 points is your y value became negative and your x value stayed the same. So your mapping notation would be, I have a transformation, and what happened was I kept my x value the same and my y value ended up becoming the opposite. So this is an example of a reflection over the x-axis. Now I'm going to do a reflection over the y-axis, which is this line right here. So reflecting point A over that line, A is 1 unit away from that line, so A prime will be 1 unit away on the other side. B is also 1 unit away, so B prime would also be 1 unit away on the other side. And C is 1, 2, 3, 4 units away from the line of reflection, so C prime would be 4 units away on the other side. So this is what your figure looks like, and now we're going to determine what happened to do our mapping rule. So let's look at point A again. Point A was originally at the ordered pair, -1, 2. And now A prime's at 1, 2. So this time my x value became negative and my y value stayed the same. So my mapping rule would be that my x value is negative, my y value stayed the same. So if you ever see a mapping rule like this, that would mean that that was a reflection over the x-axis. And sorry, part of my triangle just disappeared. There we go. All right, and then the last one that we're going to learn is a reflection over the line y is equal to x. So y is equal to x can also be written as y is equal to x plus 0. Your y-intercept 0, your slope's 1. So up 1 over 1, up 1 over 1, or you could go down 1 over -1, and so forth. But this is the line that we're reflecting our triangle over. Okay, so point A, we got to travel perpendicular to that line, is 1 whole diagonal of a square and 2 whole diagonals of a square. So if I go 1, 2 whole diagonals on the other side, I wind up with A prime being right here. And let me actually draw it this way. Okay. B is 1 whole diagonal, 2 whole diagonals, 3 whole diagonals, and a half of a diagonal. So going, so going 3.5 diagonals away on the other side, we wind up with B prime being right here. And then C is 1, 2, 3, 4, 5, 6 whole diagonals away from our line of reflection. So C prime would be 6 whole diagonals away on the other side. So C prime would be located here. And this is what your triangle looks like. Now, let's look at the rule. A was originally at 1, -3, and A prime is at -3, 1. So what happened between my x and my y values is my x and y value flipped around. So my coordinate rule for this one would be that I took my x and y value and I flipped my x and y value around. So if you ever see a mapping rule like this, that would mean that this was a reflection over the line y is equal to x. All right, so moving on to the next page, we are actually going to save these 3 problems for our next video.